All right, geometry, we're back with another video. All right, Miss Keaton took her about 20 minutes to do Unit 5 for the study guide, because once again, Miss Keaton left her notes in her classroom. She definitely did not take a picture of her answer key before she, Miss Keaton just, so I had to do everything from scratch. All right, so when it comes to circles, it's so important to understand what are the different parts of the circle, the difference between the radius and the diameter, the difference between a tangent and a secant, a difference between a chord and the diameter. All right. So as we go through this, it's important to recall those vocabulary terms, okay? You will get a formula sheet, but as I mentioned before with Unit 5 and Unit 6, a formula sheet won't be helpful if you don't understand anything on the formula sheet. If you can't recall what X, Y, and Z is, right? If you can't recall what a slope is or what the purpose of a slope or what's the importance of the distance formula, there's no purpose of you having that formula sheet because that won't be helpful. So let's go through Unit 5. All right. So starting with number 9, name the terms that best describes the given line, segment, or point. Starting with CD, segment CD. All right. CD is a chord. All right. A chord is 2 points on a circle, a line connecting 2 points on a circle. That is a chord. All right. A tangent, FG is a tangent. Remember, a tangent line different from the ratio tangent of a trigonometry. A tangent line is a line that touches 1 point on the circle. It touches a point on a circle. That's a tangent. A diameter, for example, is EC. A diameter is a chord, but it's a special type of chord because it's a chord that goes through the center. All right. If we know where our diameter is, that chord that goes through the center, we know that we have a semicircle and we can understand that that's 180 degrees and whatnot. AB is the radius. Remember, a radius is the distance from the center of the circle to the edge of a circle. Doesn't matter. And here, let me get my. Doesn't matter if A to B or let's say A to H, A to C, A to E, A to D. That's all. Those are all radii. Those are all different radius. Okay. A radius is the distance from the center of the circle to the edge of the circle. That's a radius. All right. And the radius is always half of the diameter. The radius is half of the diameter. Hint, hint. All right. H is the point of tangency because if FG is the tangent line and goes through the point H is the point of tangency. And last but not least, A is the center of the circle. A is the center of the circle. All right. That's also what we call circle A. That's the name of the circle. All right. Once again, CD is a chord, 2 points on a circle, a line connecting those 2 points, a segment connecting the 2 points on the circle. FG is a tangent line because it hits 1 point on that circle. EC is the diameter because it's a special type of chord that goes through the center of the circle. All right. AB is the radius, is the distance from the center of the circle to the edge of the circle. H is the point of tangency, and A is the center. So given the circle below, find the value of x. So as you see here, we have 13x plus 2 degrees. We have to find what x is. So we could have done this in multiple ways. First things first, starting out with that vertical angles are congruent. So if AED is 48, BEC is 48, vertical angles are congruent. We learned that in Unit 2, vertical angles are congruent. But what I highlighted, and once again, there's multiple different ways to do this. I highlight like, here goes a semicircle. DB is a diameter. The diameter goes through the center, which will represent a semicircle. And if a circle has 360 degrees, a semicircle has 180. Half of a circle is 180. So if we add the 48 plus the 13x plus 2, that should equal 180. If I add 48 plus 13x plus 2, that should equal 180. All right, so I combine like terms. 48 plus 2 is 50. We leave the 13x alone. I subtract 50 on both sides because what you do to one side, you have to do to the other. 180 minus 50 is 130. Then so I have, what I'm left with is 13x equals 130. And once again, I got to think about 13 times some number is 130. So for us to figure out what that number is, 13 times some number equals 130. I do the opposite. I divide by that 13. 130 divided by 13 is 10. X equals 10. That's one way of doing it. That's one approach. That's a common approach that I see that many students do. Another approach is understanding, once again, that vertical angles are congruent. So if that's 48, if angle BEC is 48, that means angle AED is 48, right? And once again, a semicircle has 180 degrees. So I do 180 minus 48. 180 minus 48 is 132. 180 minus 48 is 132, because if we add those two together, they should equal 180. Well, 180 minus 48 gives me 132. And since this is a central angle, there's a difference between a central angle and an inscribed angle. A central angle is where the two sides meet at the center, where the two sides of the angle meet at the center of the circle. Well, we know the degree of the arc is equal to the degree of the central angle. So I've set 13x plus 2 equal to 132. Subtract 2 on both sides, because I want to get the x by itself. That's always the goal, so always remove whatever's attached to it. I always think about PEMDAS, right? Multiplication. I do it backwards, right? Or what they call it now, gems, grouping, exponents, multiplication, division, subtraction, addition, whatever they call it now. All right. Just because they changed the name of math doesn't mean math is changing. Fun fact. They're just trying to make it simpler. So I subtract 2 on both sides. I subtract first, which leaves me 132 minus 2 is 130. And once again, 13 times some number equals 130. I got to figure out what that number is. Once again, x just represents a variable. Don't think too deeply about x and y and a and b. It just represents the unknown. I'm trying to figure out what is that unknown. So we do 13 times some number. In this case, we're calling it x, right? It's like going back to 5th grade, where we just put a box, like 13 plus a box equals 17, or 13 plus, I don't know, a question mark or a squiggly line equals 15. You have to figure out what that box or squiggly line represents. Same thing. We're just giving it a variable. We're just giving it A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Or we can use Greek letters. People use Greek letters. That, Greek came first, but that's it. But same habit. 13x equals 130. I divide by 13 and x equals 10. Given the circle below, what is the measure of arc, MN? Arc, MN. All right. So first thing first, this is an inscribed angle. An inscribed angle is different from a central angle. A central angle meets at the center of the circle, right? My two sides, the two lines that meet at the center of the circle. An inscribed angle is where they meet on a point of a circle. M is a point on the circle, and my two lines meet at that point. So when it comes to an inscribed angle, your angle is always half of the arc. Your angle is half of the arc, meaning some number divided by 2 gave me 54. Some number, let's just call it x, divided by 2 gave me 54. How can I figure out what that number is? If this is x divided by 2, to get x by itself, and this is x divided, I'm going to multiply both sides by 2. 54 times 2 is 108. So that arc measurement is 108. NL is 108. All right. But it says find MN. If we know that N to L is 108, I'm asked to figure out what MN is. And as you see here, there's that congruent symbol right there. That means that this arc is congruent to that arc. That arc is congruent to that arc. So once again, we know there's a total of 360 degrees in a circle. So I do 360 minus 108. That will give me 360 minus 108 will give me MNL. Or I said MNL. NML, LMN. Let's say LMN. 360 minus 108 will give me LMN. LMN is split into two congruent halves. LMN is split into two congruent halves. How do I know it's split into two congruent halves? Because we have our congruent symbol right here. That symbol means they're congruent, means they're the same measurement. So if I know if I add LM and MN, and they should equal 252, but those numbers have to be the same exact numbers because they're congruent, they're equal halves. Equal halves. I divide 252 by 2, and that's 126. Given the circle below, what is the measure of angle Z? All right, so we have a quadrilateral inscribed of a circle. All right. Remember that the angle is equal to half. This is an inscribed. The angle is equal to half of the intercepted arc. That's the keyword, intercepted arc. So here goes angle X. But first things first, opposite angles are supplementary. Opposite angles are supplementary, meaning they equal 180. And here it goes. So Z and X are, so Z plus X are supplementary. I can figure out what X is. And how can I figure out what X is? Well, you have an inscribed angle here. And the inscribed angle is equal to half of the intercepted arc. The inscribed angle is equal to half of the intercepted arc. You will have a formula sheet. But once again, you have to ask yourself, are you looking for the arc or are you looking for the angle? Are you looking for the arc or are you looking for the angle? The angle is half of the arc. The angle is half of the arc. So if I have this arc, I think that's V to Z is 86 and Z to Y is 62. Those two arcs are my intercepted arc for angle X. Those arcs added together are my intercepted arc for angle X. 86 plus 62 is 148. Half of 148 is 74. So angle X is 74. And since Z and X, angle Z and angle X are supplementary, meaning when you add those two numbers up equal to 180, and X is 74, 180 minus 74 is 106 degrees. So let me go back for a minute. I want to go back for a minute. Number 11. Find MN. I have to first figure out what N to L is. This is an inscribed angle. Your angle is always equal to half of the arc. Your angle is always equal to half of the arc. Meaning, whatever my arc is, NL, let's say NL divided by 2 gave me 54. That means 54 times 2 gave me NL. All right. Here I have the opposite where I know the arc, but I need to find the angle. My angle is half of the arc. Once again, my angle is half of the arc. Half means to cut something by 2. So 86 plus 62 is 148. That's my intercepted arc. That's the arc between the two lines. It's the arc between the two lines of my angle. Half of 48 is 74. If I know that Z and X are supplementary, meaning that when you add Z and X together, they should equal 180. 180 minus 74 is 106. Given the circle below, what is the measure of angle QTR? So I highlighted QTR here in yellow. I scanned the document so you really can't see it well. But you see, I don't have my intercepted arcs here for QTR. I don't have my intercepted arcs. My intercepted arcs would be QR and PS. Those would be my intercepted arcs. I have my intercepted arc for the supplementary angle. I have my intercepted arcs for the angle supplementary to QTR, which is STR. You can use STR or PTQ. It's up to you. I use STR. STR and QTR are supplementary angles. STR and QTR are supplementary angles. Oops, that's an arc. I need an angle. Haha, symbols are important. Symbols. So I found the angle measurement STR is half the sum of the intercept of arc. So once again, you will have a formula sheet, but you got to ask yourself what is happening in this picture. What's happening is that you're looking for an angle measurement that's between, it's two chords that are intersecting, two chords that are meeting in the circle. Find the angle measurement of those two chords, those two segments meeting inside the circle. Is half the sum of the intercepted arcs. So I add SR plus PQ, 141 plus 95 is 236. I take half of it, which is 118. So STR, PTQ is 118. And since STR and QTR form a straight line, which we know a straight line is 180, 180 minus 118 is 62. So let me run that back real quick. It says find angle QTR. Find angle Q. Here we go. QTR. I don't have my intercepted arc measurements. I don't know what my intercepted arcs are. But what I do have is the intercepted arcs of 141 and 95, which would tell me the measurement of angle STR. STR and QTR form a straight line, which we know there's 180 degrees in a straight line. So I first figured out the angle measurement STR. Remember, these are two chords that are meeting inside of a circle. You will have a formula sheet, but if you don't know what's happening, that formula sheet won't be helpful. I have two chords meeting inside of a circle. Inside of a circle, not outside of a circle. I don't have two tangent lines, two secants meeting outside of a circle. I have two chords meeting inside. It's an interior intersection. All right, if you're going through your notes, this is the interior intersection. STR is equal to half of the intercepted arcs. 141 plus 95 is 236. That's the sum. Half of 236 is 118. And since these two lines, these two angles are supplementary, they form a straight line. 180 minus 118 is 62. What's the measurement EFG? So I think the next couple, just trying to think. Yeah, the next few are exterior intersection. Once again, I'm naming this if you're going through your notes of Unit 5, Unit 7, circles, just the circles packet. It says find the angle measurement EFG. So this is the exterior intersection. I have two secants. These are secants. What's the difference between a secant and a tangent? A secant goes through 2 points in a circle. A tangent touches the circle at 1 point. So these are two secants. So they said find EFG. So once again, the formula here is that the angle is half the difference. In this case, we're talking about the exterior intersection. So we're talking about half the difference. So 123 minus 37. The difference between 123 and 37 is 86. Half of 86 is 43. So that's the measurement EFG. So if you're looking at your formula sheet like, I don't know what I'm doing here. You're looking at two secants. And there, the formula sheet would tell you, I guess here's another important thing, the difference between finding segment lengths and finding arcs and angles. There's a difference in the formulas for finding the length, how long it is, versus the angle measurements of two sides, or where two lines meet. Finding the angle measurements when two lines meet. There's a difference between lengths and angles. There's a difference between segment lengths and angle measurements. There are a difference between angle measurements and segment lengths, or a line, how long a line is. I'm just trying to get that out there. Okay. So once again, I'm looking for my angle measurement here, not how long a side is, but my angle measurements. Plus, I think it's helpful if you think about what's given to you. The numbers, my numbers are given to me in degrees, meaning I'm looking for an angle or arc if I'm looking in degrees. So half the difference. So the difference between 123 and 37 is 86. Half of that is 43. Given the circle below, what's the measure of UV? So once again, I highlighted where UV is. This is what I'm looking for. So the first step is, if I know that angle T is 51 degrees, and angle T is half the difference of the intercepted arcs, half the difference of my intercepted arcs. Here goes one intercepted arc, which is 70. My other intercepted arc I needed to find. So how I found my intercepted arc SV was I set this up half. Angle T is equal to half the difference of the intercepted arcs. Angle T is 51 degrees. 51 degrees is equal to half of my intercepted arcs. So SV, which is unknown, minus 70. Or SU is 70. SU is 70. So I multiply by 2 on both sides to get rid of this 1/2 first. I multiply both sides by 2 to get rid of this 1/2 first, which gives 102 is equal to SV minus SU. And once again, SU is 70 degrees. So I add 70 and SV is 172. All right. So SV is 172. And if you don't understand this concept, I put the name of the concept at the very top. YouTube a video, go to Khan Academy. Finding angle measurements on arcs, measures in a circle associated with central angles, inscribed angles. Well, this is two intersecting secants. So two intersecting secants here. Once again, I have. Actually, this is a secant and a tangent. Excuse me. This is a secant and a tangent. Because this is a tangent line. This is a secant line. So since I know that SV is 172, remember a circle is 360 degrees, so I know this is 70 here. This is 172. I need to figure out what's the rest of this 360. So 360 minus 172 minus 70 is 118. You could do it in different ways. I also did. You could add 172 plus 70 and subtract that number from 360. It's all depending on what you want to do. Same thing. 360 minus 172 minus 70, or 360 minus this sum of 172 plus 70, which is 118. SVU or UV is 118. So if you don't understand the concept, once again, the name of the concept is at the very top. This is intersecting secant and tangent. 14 is two intersecting secants. 13 is two intersecting chords. 12 is solving problems related to quadrilaterals inscribed of a circle. YouTube those concepts. And there's more. See, I knew this one was going to be longer. So here we go, finding angle measurements. So we're finding X. So as you see here, X is this 9X plus 26, which is part of angle K right here. It's part of angle K. And this is two intersecting tangents. So once again, 14 was, or let me start with 13. 13 was two intersecting chords. 14 was two intersecting secants. 15 is a secant and a tangent intersecting. And 16 is two intersecting tangents. Okay. So the angle measurement, which is angle K, and angle K is this 9X plus 26, is equal to half the difference of the arcs once again. Whenever you're having intersecting secants, tangents, or a secant and a tangent, it's always going to be half the difference of the arcs. So 9X plus 26, that's angle K. That's angle K here. Angle K is equal to half the difference of the intercepted arcs. So LJ, well, I have 251. We're just going to put 251. Minus 360 minus 251 is 109. And how do I know it's 360 minus 251? It's because when you look at this circle, your intercepted arcs, once again, it's the larger one. The intercepted arcs is the arcs between the two lines of the angle. So here goes this 251. And once again, a full circle is 360 degrees. So 360 minus 251 is 109. So half the difference. So 251 minus 109 is 142. Half of 142 is 71. My goal is to get X by itself. All right. 17. If AB and BC are tangent to circle D, AB is 15 inches, DB is 17. Find the perimeter. Perimeter is the fencing around. So what you know about tangents is that if two tangent lines come from the same external point, they are congruent. So AB and BC are both 15 because they're both tangent lines that come from point B. You know that DB is 17. And what you also know about tangent lines is that a tangent line meets the circle at a 90-degree angle. And the tangent line and the radius meet at a 90-degree angle. The tangent line and the radius meets at a 90-degree angle. So I use Pythagorean theorem to figure out that missing side length. I used the Pythagorean theorem to figure out the radius. Use Pythagorean theorem to figure out the radius, which the radius is 8. So if this is 8, that means that radius is 8. And once again, perimeter just means to add up the sides of the triangle. So 15 plus 8 plus 8 plus 15, 15 plus 8 plus 15 plus 8 is 46. And we figured that out in the problem, I think, number 3. So now we're finding segment length. So once again, there's a difference between 13 through 16 where you're finding angle measurements versus 18, 19, I think even 20. Yeah, 18, 19, 20 where you're finding segment lengths, right? Let's talk about how long something is. How long is my segment? How long is that line? So you will have a formula sheet that will talk about intersecting secants, intersecting chords, intersecting secants and tangent. But you will have two formulas. One of the formulas represents the formula of angle measurements. The other formula represents the formula of segment lengths, the length of a segment. So this is two intersecting chords. Number 18 is. And the formula there is that if you have two chords and I wish I could write with this better. This stylus is not helping me write. The formula is A times C. So you multiply one of the segments, one of the chords, equal to the other chords multiplied times BD. So 12 times x minus 2, that belongs to the same chord, equals to 3 times 3x minus 1, which that belongs to the same chord. You have QR and NP. Those are two separate chords. You distribute 12 times x minus 2. Well, 12x minus 24 is equal to 3 times 3x minus 1. Distribute that 3, 9x minus 3. And you solve for x. X is 7. But it says find QR. QR is 12 plus x minus 2. Right, I want to figure out what's the entire length of it. NP is intersecting QR. So that's how I got split up, is because QR is being intersected by NP. So 12 plus 7 minus 2. Well, 12 plus 7 is 19. 19 minus 2 is 17. (19) is two intersecting secants. So once again, there's on your formula sheet you will have there's going to be two secants. One formula is going to be for segment lengths. The other formula is going to be for angle measurements. You need to be mindful of which formula you're using, whether you're finding angle measurements or segment lengths. The formula here is A times A plus B equals C times C plus D. So you take one secant, do 6 times 6 plus 2x minus 2 equals 5 times 5 plus 31. Right, D alpha is one secant, DB is another secant. Making sure you're multiplying those secants with themselves. 6 times 2x plus 4, 6 minus 2 is 4. That's where that 4 comes from. Then you distribute 12x plus 24, 5 plus 5 plus 31. You can go ahead and add in the parentheses, which 5 plus 31 is 36. Some people may distribute that 5, but we know 5 times 5 is 25. 31 times 5, I believe, is 155. Let me double check here. 31, because 30 times 5 is 150. 1 times 5 is 5, so 155. So 155 plus 25 is 180. So you can distribute or you can add in parentheses first. You still get 180. Once again, your goal is to get x by itself. 180 minus 24 is 156. 156 divided by 12 is 13. And it says find EF. EF, find the length EF, not just to find x, find EF. EF is 2x minus 2, and I substitute in 13 for x. 2 times 13 is 26. 26 minus 2 is 24. All right, let me hit these last few problems. Then we're taking a break so I can do the Unit 6 and Unit 7 part of the study guide, all right? Number 20 is secant and a tangent here, and the formula is the tangent squared equals the secant, tangent squared, so x squared equals 4 times 4 plus 12. Once again, you can go ahead and add in the parentheses first. 4 plus 12 is 16. 16 times 4 is 48. Or you could distribute that 4. 4 times 4 is 16. 12 times 4 is 68. And 48, excuse me. And 48 plus 16 is 64. Then you take the square root. Since this is x squared, we want to figure out what x is. You take the square root, and that's 8. 21 is to find the length of EG. I want to figure out the length, not the measurement, the arc measurement in degrees, but how long of it is it part of the circumference. So we have this formula of x times the circumference of the circle divided by 360. All right. And how did I figure out what x is? X is the degree of the arc, or the degree of the degree of the central angle if you're given the central angle. But what we're given here is the inscribed angle. And we know the inscribed angle is always half of the arc. The inscribed angle is half of the arc. So 52 times 2 is 104. That's the degree of the arc. Times 2 times pi times radius. They tell you e to h is 15, so your radius is 15. You plug that in your calculator, 104 times 2 times pi times 15 divided by 360, and you get 27. If the radius of the circle below is 9, find the approximate area of the shaded region. So you want to find the area of this sector, part of the circle, not the entire circle, but part of it. So it says find the area of the shaded region. The unshaded is a 90-degree angle. And how do I know it's a 90-degree angle? Because that box represents 90 degrees. And full circle is 360. So 360 minus 90 is 270. That's my x. That's the degree of my central angle. The degree of my arc is 270. Times pi times radius squared. Pi radius squared is the area of a circle. And once again, we're talking about part. And the reason why because we're talking about the area of part of the circle, not the entire circle. So that's where 270 divided by 360 comes in, because that's part is 270 degrees of the 360, right? Times the area of the circle. Same thing with 21, right? It's part of the circle, the degree of the arc divided by 360, right? Because there's total 360 degrees in a circle. We figure out how much of that arc, how much is the degree of that arc is part of that full circle. Then we multiply it by the circumference. So 22 is kind of similar, but we're multiplying it by the degree, the area of the circle. So 270 times pi times 9 squared divided by 360. You plug that in your calculator, you get 191. The only thing that's not on your formula sheet is the equation of a circle, because at this point we should be experts at the equation of a circle. This is not our first time working with the equation of circles. We've been working with it for the past, I think, 4 months, honestly. Since, let's say 3 months. So since around February, mid-February, we've been working with the area of a circle. So this is the first time. This is not the first time you've seen it. So that's why you don't have that equation on your formula sheet. So identifying the center, radius, and diameter of a circle from a given standard equation. So given the equation of the circle, which correctly gives the center and radius of the circle. So remember, the equation of a circle is x minus h squared plus y minus k squared, where h and k is always the center of the circle. H and k are the center of the circle. And it has to be a minus, right? X minus h. So if you have an x plus, a double negative becomes or when you're subtracting a negative, that becomes plus. So that's how I know it's a -5. Then it's y minus 1. Once again, the standard equation has a minus in here. All right, that's why it's y minus 1. So that means that's a positive 1. And my radius squared is 16. Radius squared, let me make sure I write this out. Radius squared is not the same thing as r divided by 2. I see that a lot. They say, oh, my radius is 16. That means if my radius squared is 16, that means my radius is 8. No. R squared is different from R divided by 2. Squaring a number is different from dividing a number by 2. So if you know your radius squared is 16, well, what number multiplied by itself give you 16? What number multiplied by itself, not multiplied by 2? R squared does not mean to multiply a number by 2. R squared means to multiply a number by itself. All right, that's what the point of exponent is, to tell you how many times to multiply a number by itself. So if I had R cubed, that means to multiply it 3 times. So a number multiplied by itself to give you 16 is 4. And so that's why my answer is B. A circle with a center at 2, -3 passes through the point -1, -8. Write the equation of a circle. So I start with this. I went through a process of elimination, starting with the center of the circle. If I know the center is 2, -3, remember the formula is always x minus h squared. So x minus 2 squared plus y minus k squared, y minus a -3 squared, which once you get a double negative minus a negative is plus. So I eliminate the ones that has y minus 3. Then I had to figure out what my radius squared is. So all I did was plug in, if I know my center h and k, this is h and this is k. Then x and y, this is my x and this is my y. I just plug in those values, and r squared, as you see the math here, is 9 plus 25, which is 34. And with 25, they give you your diameter. So you have to start by finding the center of the circle. Remember, your radius is half of the diameter. Your radius is the midpoint of the diameter. All right, so I found my midpoint. I found the center of the circle using the midpoint formula, which is 4, 0. So remember, your formula is always x minus h, so x minus 4 squared. So I eliminate b and d because it's x plus 4. Then once again, you can use the distance formula to find r squared between the center of the circle and one of the endpoints. So yeah, once again, if you need to YouTube video, I put the name of the concepts right here. Email me with questions. Have a good day. Unit 6. I got to do Unit 6, okay? Bye, guys.